Okay, for this week's lesson, we're going to talk about ratios and proportions. And it's important to remember that even though we can write a ratio as a fraction, it's not a fraction, it's a comparison of two things. So we're going to start by looking at granola bars. So if I have 5 blueberry bars and 3 strawberry bars and 2 apple bars, I can compare these in different ways. So if I wanted to know the ratio of blueberry bars to strawberry bars, I can write it as a fraction, so I could say I have 5 blueberry bars to every 3 strawberry bars. I could write it with a semicolon, or a colon, I'm sorry, I have 5 blueberry bars to every 3 strawberry bars, or I could write it out with the word 2, 5 blueberry bars to every 3 strawberry bars. And you usually can label it, or you can just leave it with your numbers depending on what the question asks you to do. This is an example of a part-to-part ratio, because I'm comparing two pieces. Now, if I was comparing the blueberry bars to the total number in the box, that would be a part-to-whole ratio. So if I was doing blueberry bars to the box, then I would say, okay, I have 5 blueberry bars to a total of 5, 8, 9, 10. Okay, and then that could be simplified to a 1-to-2 ratio. So basically there's 1 blueberry bar for every 2 bars in the box. Okay, this is a part-to-whole ratio. Okay. The nice thing is once we start having our ratios, we can actually use them to make predictions. So what I could say is if I know that there are 2 apple bars for every 5 blueberry bars, okay, so we'll say apple to blueberry. If I know that there's 2 apple bars for every 5 blueberry bars, can I predict if I had 10 blueberry bars, how many apple bars there would be? Well, yes, I can, because 5 times 2 is 10, and 2 times 2 would be 4. So I can predict. This right here is your proportion, because the proportion is 2 equal ratios, 2 equivalent ratios. So those ratios are equal. A 4 to 10 is the same as a 2 to 5 with your apples and blueberries. Okay, so that's what's nice about our ratios. So when we have a couple different ways. I'm going to kind of transition now into proportions from ratios. So ratios, comparison of two things. You can always simplify it. We have our part-to-part and our part-to-whole. When we're looking more at proportions, we've got a couple different things we can do. We can either solve them by scaling up or scaling down, and they can be comparing things. So I could say that I have... I don't even know. I'm running out of time. I'm just going to write the proportion, but these could be compared. I didn't necessarily write down what they're comparing. So I could say it costs $40 for 3, I don't know, concert tickets, which is not necessarily true, but, and then I would want to know how much it would cost for 12. Okay, so this is my proportion, and the numbers can belong to different things. The biggest thing is that when you set up proportions, you need to have the same thing on each line. So if this is talking about my money, and this is talking about my tickets, I would need to have my tickets in the same place as my money, and my money in the same place. So, we are not going to cross multiply and divide. I know that you guys think that's easier. It's not, I promise you. We are going to use what we call scaling up or scaling down, which is always going to be easier. I promise. Promise. Okay, and there's a couple different ways you can do it. So what I can do is I can look for this right off the bat and say, okay, well, I can see that there is a scale factor here, which means a number that I can multiply or divide in between. That's easy. 3 times 4 is 12. So all I have to do to make an equivalent ratio here is 40 times 4. 40 times 4 is going to be $160. So if it cost me $40 for 3 tickets, then it's going to cost me $160 for 12. That's it. So I didn't have to do 40 times 12 and then divide by 3. It's just easy enough that I was just able to, this is called scaling up. Okay, let's do another scale up problem. Okay, I'm going to do, let's say I can go for 2 gallons of gas, I can go 26 miles. And then I would like to know how many miles I can go for 8 gallons of gas. Okay, so I can look here and say that 2 times 4 is equal to 8. And then I would just need to do 26 times 4. I can come down here, 26 times 4, 24, 8, 9, 10. So 104. And that would be my answer. And that's it. That's all there is to it. Okay. Let's do a scaling down where we would actually divide. So for scaling down, let's say that I had 18 workers for every 3 managers. I want to know how many workers I would have if I only had 1 manager. Okay. So again, I still have my comparison of 2 things. My managers are on the same line, my workers are on the same line, but now I can see that I would multiply to go this way, but because my numbers are over here, I'm going to need to just divide by 3, because 3 divided by 3 is 1. And so I would do the same thing on top, 18 divided by 3. So X is going to be equal to 6 workers. We'll do another one. Okay, so I could have 280. Let's say 280. I can't think of anything. I'm drawing a blank. Give me a second. I'll think of something. I can travel 280 miles in 4 hours. How long would it take me to travel 70 miles? Okay. So here I know that my relation to 28 and 7 is 4, so 280 divided by 4 is going to equal 70. 4 divided by 4 is going to be, X is going to be 1 hour. Okay, so the next example I'm going to do is one where it's not going to look as easy right off the bat, but we're still going to do our scaling up. So I'm going to say that I have, in this pet store, let's say we have 2 cats sold for every 6 dogs sold. And if there's 3 cats sold, how many dogs would be sold? Okay, so this is where this looks tricky because there's not a very good scale factor between 2 and 3. But what's nice about this ratio here is I can simplify 2 cats and 6 dogs down, and I can say that that's 1 cat to every 3 dogs. I just divided both of those by 2. Now I still have a really nice scale factor. 1 times 3 to get to 3. 3 times 3 is going to be 9 dogs. So again, I know that this problem especially, it's not hard to just cross multiply and divide, but that's not the easiest way to do it. When you get to the more complicated numbers, it will be easier to just simplify and then use your scaling up. Okay, so we are going to, so this one is all scaling down. Scaling down. Okay. So the next thing we need to talk about is unit rate. And unit rate is just going to be a comparison to 1 unit. So, for example, if I can go 630 miles on 18 gallons of gas, basically this is going to want to know, and because it's not going to give you the whole proportion, you're going to set up the proportion. So if it says find the unit rate for 630 miles and 18 gallons of gas, you're going to want to know how far you can go on 1 gallon of gas. So I'm taking it down to 1 unit. So again, I've done this. Now I can do my scale factor of dividing by 18. Okay. At this point, we're going to go ahead and divide because I just don't necessarily do that in my head. So I'm going to do 18 into 630. Goes into 63 3 times. 3 times 18 is going to be 54. 9. And I believe 18 times 5 is 90. And so we are going to be able to go 35 miles on 1 gallon of gas. That's the unit rate. Another example of unit rate is, we have 4 buses for 112 children. So how many buses are we going to need? Or how many children are going to be on 1 bus, basically. So I'm going to divide by 4. I'm going to do the same thing to the children. Divide by 4. 112 divided by 4. 8, sorry. So 28 children per bus. If you have any questions on ratios, proportions, or unit rate, make sure you come see us.